Awesome. Yeah, thank you. Thank you all for coming and being here. I know it's kind of late in the conference, so I hope to kind of wake you all up, I guess. So my name is Moshe Zadka. My website is cobadism.com, where you can find every way of reaching out to me known to humankind. And today I want to talk to you about modeling alert quality. I want to start with an acknowledgement of country. I live in Belmont in the San Francisco Bay Area Peninsula, which is the ancestral homeland of the Ramaytush Ohlone people. So before we talk about what good quality alerts are and what bad alerts are, let's make sure that we all are thinking about the same thing when we think of what are alerts. So let's make sure that we have our terminology tied down here. So kind of like, I guess like the 1-minute intro to what is monitoring in general. We have a system, right, that does something. It's not, monitoring system, right? It's a system that, does something that someone actually enjoys. That system sends some monitoring data to an aggregator. We have an event. That means that we run a query against the aggregator, and that query returns a value that's atypical. This is still not an alert. This is an event, right? So an event can cause an alert, and there's two kinds of alerts that kind of we can think of. One is a low priority alert, which means this event is not good, like we're not happy about it, but it's not urgent. Deal with it when it's a good time, on business hours. The other kind of alert is the high priority alert. It means fix it as soon as possible, right? If it's 2 a.m. on a Saturday, you need to wake up now and start figuring out what's wrong and how to fix it, because this is a big problem, right? This is like the high priority alert, and this is the focus of the talk. So when I say modeling alert quality, I'm talking about this. There was like an event that produced a high priority alert, and we want to know if that was good or bad. So what are like the component pieces that go into the alert quality, right? Like how can we kind of start teasing it out? Like what is it made of? So it's easier to kind of measure if we know what kind of alerts we have. And for the purposes of this talk, I'm gonna classify our alerts into 3 kinds, and I think they're gonna be interesting kinds. So the first are true alarms. It means a high priority alert has gone out, and there was an actual problem that harmed someone and that we actually need to fix, right? These are ideally the raison d'etre of why you have an alert, right? It actually woke someone up because they needed to fix something, and then they fixed it, and then everything was better, right? This is kind of the good stuff, right? Ideally. Then there are the false alarms. If you're like me, and have been in this business for like, more than an hour, then you have probably experienced that, right? Your thingy goes off, right? Whatever you're doing, PagerDuty, OpsGenie, whatever, and you look at it, and nothing has actually gone wrong, right? This is a false alarm. Some people use terms like false positives, and like it's kind of hard to kind of keep them together. So my friend Nelson Elhage is kind of credited with like coming up with these terms, which I feel like are impossible to kind of confuse. So false alarms. And there's another kind of alert, which is really interesting because it's not an alert, which are the missing alarms, right? These are the alerts that should have been sent out and were not. Something went wrong, something that we did want to capture in our alerting system, and there was no alert. And you might think, well, that's kind of weird, right? Why is that part of your alerting quality? That's not an alert. How can you put it in the measurement of alert quality? Well, if you think about it, what are you changing? Like when we think of like why are we measuring alert quality? What we want to capture is some measurement of like, is a change in the alert configuration gonna serve us or not? One big change that we can do is add an alert or remove an alert. adding an alert turns something that used to be a missing alarm into a true alarm, and removing an alert makes something that used to be a true alarm into a missing alarm, which means the missing alarms, even though they're not alerts in our system, are a critical part of what we measure when we measure alert quality. The hypothetical alert that when we think of like the quality of our alerting system, they are really important to measure. So when we think of like how we measure alert quality, it's probably easier to think of like measuring each of those and then somehow aggregating those measurements. And I'll try to kind of talk about how we kind of aggregate and how we measure each of those. So it's kind of easier to think about how to measure each of these separately. So let's start with the true alarm, because that's the good stuff, right? This is, if you didn't have any true alarms, why do, like there's no use of having alerts, right? The true alarm is the reason you have an alerting system in the first place. So, but this doesn't mean that all true alarms are created equal, right? Some alerts are still going to be better than others. So what are the most important parameters in alerts? So one of the most important parameters, especially in a true alarm, is like the time that it took. And when you think of the time, it's of course useful to kind of think of the time holistically, but it's kind of good when we start measuring to measure the time in parts. So how does the timeline of a typical alert happen? Well, an alert doesn't fire when the bad thing starts, usually, right? If only because the speed of light is a thing. But even beyond the speed of light, usually it needs to gather some data to make sure it's not a purpose of noise, and then there's like processing speed and so on. So there's a time from when things started to go bad, people started getting hurt by whatever this is that wasn't behaving correctly, to the point where there was detection, right? To the point an alert was sent out. So this is an interval that you would like to make as short as possible. Then the other interval that you would like to make short as possible is the detection to acknowledgement, meaning between an alert was sent out and someone has shown that they have awareness of it. You could think of that like detection to awareness, but that's really, really hard to measure because it's impossible to get in someone's head. So it makes more sense to say detect to acknowledge, right? When was the first time that someone got on Slack or pressed the acknowledge button or did something that showed that they have awareness of the alert, right? That kind of has a proof of the awareness of the alert, right? Then, like, you can only diagnose an alert after you have an awareness of it, but at some point you diagnose it. You can think of diagnosis as all kinds of what is the true meaning of diagnosis. Here I'm going to take a very utilitarian definition. The diagnosis that I care about is when did you know what was the real fix? You don't know that in advance, of course, but in retrospect you can say this was the time when we figured out what the real fix was. So that means if you had several false starts, right? You said, oh, well, I should probably change this parameter, and you change it, and then it wasn't the parameter that you needed to change. That wasn't the true diagnosis. The true diagnosis was the one that eventually led to the right fix, but this is not the time until the right fix was deployed, right? This is the time that you knew what the right fix was. So you only know that time after you have finished the remediation, but you can then figure out what that time was. And then between you figured out that time, again, because of speed of light and also because humans, there is some interval of time between your diagnosis of that and the remediation, that you have remediated that stuff. And again, you can think that these things are not super well defined, right? What is true remediation? Is it, if you have solved 50% of the issue, is that remediation, or it's 100% solved? Is it true remediation? You can do all kinds of stuff, like you can, do all kinds of averaging out, right? Like the time that it had 50% is 50% less time, and then you can add it out. You can do some sort of thing that will kind of have some reasonable value that you can then put in the thing, right? So then you have all these numbers, and these are the numbers for that specific true alarm. So now you have some measurement, right? These are not necessarily all the measurements that you have for the true alarm, but these are some of the most important measurements that you will have for this true alarm because it's important. Weirdly enough, missing alarms are not very different from true alarms, right? One of the biggest differences is that detection, well, it still happened, right? Somehow, you were made aware that this thing went on, right? Maybe someone emailed you, maybe someone called you and was really upset. Maybe someone shouted in your ear because, you went back to the office. However it was, somehow the awareness, reached you, right? Like there was someone who figured it out, right? Maybe customers went on Twitter and marketing noticed the Twitter and they figured it out. It doesn't matter, but there was some detection, right? So again, speed of light and also other stuff meant that start to detect, was an interval that's probably bigger than 0. And again, from the time it was detected to the time that you have proved awareness of this issue, took some time. And same thing, acknowledgement to diagnosis. And after the detection, the flow is pretty much the same, right? Like it doesn't matter how you became aware of the issue. Ideally, you solve it anyway. So same thing, acknowledgement to diagnosis, and then diagnosis to remediation. Same caveats as I have given earlier. So this is how you measure a missing alarm. A false alarm is going to be missing a few of these steps, right? So you still have detection to acknowledgement. You notice you don't have start to detect because there is no start, nothing happened, right? But there is, how long did it take between the detection to acknowledgement, right? How long between the alarm was fired and someone acknowledged it? Because that time, there was an alert in the air, and anyone who saw did not know what the state of this alert was. Is anyone even looking at it? And then you still have to go through the diagnosis, right? From the time you became aware, you went through the diagnosis, and however many steps it took, eventually you decided that this is a false alarm, that nothing is actually wrong. And for a false alarm, there are no more steps. You're done. So this is kind of the path of those things. And it's like one important measurement is like that, like you don't want to just measure the whole time, and I'll kind of cover later why it's kind of important to break out these things, but also important to figure out how they break down. So what are the costs involving in alerts? So obviously any false alarm is pure cost. If you, took down your entire alerting infrastructure, just literally removed, PagerDuty configuration from your stuff, you would remove all the costs involved in a false alarm, right? The false alarm is pure cost. There is another kind of alarm that is also pure cost, which is a useless alarm. A useless alarm is when it detects something true, but not first, right? If users come to you and say, hey, your thing is broken, and then 2 minutes later the alert fires and says this is broken, it's technically not a false alarm, but it's not helping, right? It is a pure distraction, right? You were already in the middle of diagnosing or fixing or acknowledging, and then an alarm came, and again, if you had removed your entire alerting infrastructure, you would have been better off, right? This is a pure cost on the part of the alerting infrastructure. So whenever you measure alert quality, you probably want to put those things on the pure minus side, right? Those are pure overheads for the alerting infrastructure. And this is important because we're gonna I'm not telling you to get rid of your alerting infrastructure, right? This is not hopefully what I'm standing up here and saying, but this is the reason to get rid of your alerting infrastructure. So if you decide not to get rid of your alerting infrastructure, there probably has to be a good reason, which is that it's delivering some value that is offsetting these costs. So you can think of delivering value in terms of What if we didn't have these alerts? Well, so it might take extra time to remediate. And notice I didn't say extra time to detect, right? All the steps from start to diagnosis, to remediation, can be shortened by a good alert, right? And since we're talking about, alert quality, we can think of like things we can do to our alerting system that will make those things better. So obviously, if you use, so first of all, of course, start to detect, you can improve that, right? You can think of an alert that uses smarter rules or that needs less data or, uses the monitoring data smarter so that start to detect time is better, right? That would be a better alert, assuming it doesn't increase the cost on the other side of false alarms. You can think of an alert that makes acknowledgement easier, right? If the alert comes in with a button that you can press to acknowledge, then detect acknowledgement can be made shorter. If the alert comes in with a lot of monitoring data that helps you diagnose faster, then acknowledge to diagnosis can be made shorter. And if the alert comes in with either a button or a link to a runbook or all kinds of things that help you remediate faster, then diagnosis to remediation can be made faster. So when you think about how am I justifying even sending an alert, well, the better off your alert will be, the more justified you'll be in sending that alert. So when you think of that in their terms, right, that's ideally what it reduces compared to having it as a missing alert and detecting it via some other means. For example, marketing telling you that customers are complaining on Twitter. So you can think of alert quality as its value, right? What value it gives you, right? It reduces the cost because of the alarm, right? The cost of total fixes. But you have to pay the cost of the false alarms and the useless alarms that are kind of more or less indistinguishable. So you're going to have to break down some of these costs, right? Which means you're going to have to gather some data, and then you're going to have to make an estimation. And this is important. All measurements in general, this is a general theory of measurement. A measurement is always a process of estimation, right? If you measure your height, you're not getting the true value of your height, right? You're getting some estimation of if you put in more effort, you're going to get a better estimation of your height, right? If you, kind of look at someone and says, oh, that person is about 6'5", then that's an okay approximation. Use a tape measure, you're going to get better, right? You use a laser, you're going to get even better, but you put in more effort. You put in some amount of effort to measure to a reasonable error bar that you're comfortable with. And that means that you're going to have to put in some effort into especially measuring more costs, right? For the false alarms, you want to measure not just the time, but how many people had to work to, be involved in this whole story of the alarm going on and then not doing anything. How long did they have to work on that? How inconvenienced were they by that, right? That's an important metric, right? Because, we care about the people we work with. Also, if we think about alarms as reducing incident costs, we have to think about, how much the incident has cost us, right? That's also important to kind of estimate, right? And especially if we think about alarms as changing the cost between a true alarm and a missing alarm, we need to estimate both costs. And that's going to require gathering quite a bit of data, right? We need to estimate the loss from the incident. We need to estimate the work that went into remediation. Work that went into remediation starts with how disruptive it was, right? Was it off business hours? That costs more in many ways, right? Someone woke up and that was unpleasant, and there's kind of an amortized cost of engineer burnout. If it delayed a critical project because someone had to drop the critical project to remediate the issue, right? What if someone wasn't even needed to handle the incident, but they got pulled in, right? So all of these are like, costs of like disruption, right? There's the work that people actually had to put in, right? Like literal hours of work that get paid for, right? Work to diagnose, to test the solution, to deploy the solution. Then separate from the work, there's the loss from the incident, right? Like presumably, the reason that system was running is because it was valuable to the people running that, which means if the system is running in a degraded state, it's less valuable, right? This is separate from the work on the incident. You can imagine that a system requires very little work to bring back to a good state, but it's losing tons of money, or vice versa, right? It's not losing a lot of money, but it requires putting in a lot of work to restore. Still less money probably than it's valuable, but these are not necessarily correlated, right? This is the harm that the incident has done to us, integrated over the time that it has had, right? Especially between the start and the detect, we live with an unknown problem. We couldn't even alert customers to the existence of the problem, so they couldn't take any action to mitigate it themselves. Until we acknowledge that we don't have any confirmation of the detection, so we can't start communicating usefully. On the other hand, until we remediate it, now we're dealing with a known problem, right? We can start mitigating it by other ways, right? Just by communicating clearly with the people who need that system and seeing if they can, do stuff to contain that. There's a cost, right? There's an immediate cost, and there's potentially a reputational cost. For example, SLA missed, which means you have to actually give money or other form of compensation to customers. Business that you missed, lost transactions, and reputational harm, includes, for example, customer feedback, continued business, new customer acquisition, and this is really important because I feel like if you have a good alert, it can reduce a lot of that. Secondary incidents. Right? A lot of the time when we try to remediate a problem, I know I have, you cause another thing, right? Because you're like fiddling around exactly in the places that you don't usually fiddle around with because you need to figure out what's going on. Very easy to cause like further degradation. You have to count that in as part of the total cost. So, all of these things are things that you have to decide how much each of those is valuable to you. Because that's what would constitute better, right? If you have an alert that causes more burnout, but reduces cost of SLA, is it valuable? I don't know. It depends maybe how much burnout and how badly the burnout problem you already have, and what is the SLA cost, and so on, right? And same for all the other metrics. So you need to be very, very careful about how you make the decision about how to decide what you value. And that's a decision you have to make, right? And after you make the decision, you have to gather the data, estimate when you need to, and then you have to prioritize what you care about. You have to align it with business strategy, and you have to align it with the tactical goals of the team. What are you trying to accomplish in the near-term future? So all of these things have to come in to decide what is going to be a better alert. So if you are doing all of these things, right, which takes quite a bit of effort, right, you'll get some measurement of like, my current alerting quality, and you can track it over time. So one problem with that is that, if you're a halfway decent team, right, who cares a lot about reliability, you're not going to have a lot of outages. Each outage is a little bit different, so there's a lot of noise in the data, which means from the time you make a change until you see it reflected in the data, there's been quite a bit of lag. So it's a really badly lagging indicator. That doesn't mean you don't need to measure that, but it means it's hard to use it as a good feedback mechanism for, are we making things better, which is kind of the whole goal of this exercise. Which means, and this is kind of like, I guess, my Chekhov's gun. If you remember, I put in all these kind of like break down the terms. If you do break down all these terms, then you can see which are like the dominating terms. And then you can start saying, okay, I'm going to track the dominating terms separately because they're a good enough approximation right now for the quality. That's still not going to be a great indicator, but it's going to be slightly more accurate as an indicator because it's going to be slightly more noisy and slightly less laggy, which means it's going to be a better feedback mechanism as you track it. But that brings us to another problem. So when you track that, it's not going to handle black swans very, very well, which means you can't use it as your absolute feedback mechanism. Right? You might have to do some things that will make it worse, and based on like some kind of gut feeling intangible, you're gonna say, well, but like if we don't do that, when the really bad stuff happens, things are gonna go really badly if we don't do that. So you can't use it as kind of like a absolute guidance. There's still like some feel, and those are like the safety margins, right? I'm okay kind of making the thing I'm tracking a little bit worse if my gut feel says that I'm keeping kind of like the real problem at bay, right? If I have a few more missing alarms, but I'm not kind of completely ignoring something that doesn't happen a lot, but when it happens, it's gonna go really badly. But because you have to do all of that, you have to acknowledge Goodhart's law in like the worst way possible, right? If you are going to make this a target for like OKRs or compensation or promotion or bonuses or anything like that, we are all very smart people, right? We are all, kind of experienced. People will optimize for that, right? People will ignore all the other stuff and will start optimizing for that in lieu of optimizing for actual alert quality, which means you cannot use it as a target, right? You can only use it as a feedback mechanism that the team voluntarily tries to track and makes better because they want to make things better, right? This is not a good OKR, promotion, compensation, bonus metric. So alert quality matters, right? Bad alert quality can cause engineer burnout. I've seen that. It can cause bad customer satisfaction. Right? It's difficult to track, right? I kind of spec'd out like the added effort to the already kind of pretty heavy effort of an incident report that it would take to track all this data down. But if you want to actually improve the alerts, you need to measure that. You need to decide what you want to fix. And you need to keep iterating. You need to track that and see if it actually helps do stuff. And I think that's it for me. So thank you all. Thank you all for listening so well. And I think we have a few minutes for questions. Right, Fatima? So once again, thank you all.